All right, we're here to talk about the system constraints, the trial constraints for the fire extinguisher project. First thing I want to ask is just what is your experience working with chemicals and your background in science? And then I also want to ask about the design of this project.
So I'm Kelly Anderson. I'm one of the Science 10 teachers, and I have my bachelor's in chemistry, so I have a lot of experience working with chemicals and specifically know how to operate a fire extinguisher, so that's also what I'd like to share too.
Okay, great. We want to talk about the trial constraints, and
Okay.
could you first explain a little bit about why constraints for a trial matters regarding product design?
So the goal is that you have a successful fire extinguisher, so in order to measure success we have to have some sort of constraints in place so that we all have a level playing field, so to speak, so that we're testing this with the same conditions. Otherwise, how do we know that yours was successful compared to someone else's if they weren't the same?
So this specific type of fire extinguisher, it's a Class B fire extinguisher that's going to be using a chemical reaction, acid-base neutralization, and it kind of mimics one of the first kind of fire extinguishers that was ever invented, which is the soda acid fire extinguisher. So what are the constraints for the trial, for the trials that the students are going to run with the products that they invent? What kinds of things do they need to make sure that they can accomplish with their design?
So one of the things when you're performing your demonstration, we're going to do this in the fume hood because we'll be using a petroleum-based fire. So you'll have to make sure that you are at least 1 meter to the fire. So what that means is that you cannot get any closer than 1 meter. You can definitely like swipe or sweep and do all of those things, but you can't get any closer to 1 meter so that we're at a fair distance compared to each other.
Could it be above, to the side?
Yes,
it could be
yes,
anywhere?
that's fine. You just can't get any closer to the fire.
Okay, so 1 meter away, and what else is going to matter?
From the start, so when you start your reaction mechanism, so whenever you decide that this is going to come out, your gas is going to come out of your extinguisher, you have 15 seconds from when you initiate that mechanism to when you actually exhaust the flame.
So if it's a button, or if it's a pole, or it's something, as soon as I hit that,
Correct.
15 seconds starts, and at the end it should be extinguished in order to be a successful trial?
Yep.
Okay.
And it should also be noted that only one person in your group can handle this, so this should be a one-man job. Because in a real situation, no, right? You did the teamwork to build it and do all of those things, but in a real situation, you might be the only one there, and that's what we want to practice.
Is it acceptable for a team member to be in that 1 meter space or change the environment? Could they put a sheet or anything behind it so that...
No, we want all the same environment constraints for all.
So the flame is in here, and whoever's extinguishing it, the one person at 1 meter. Anything else?
The temperature of the room that you're in needs to be between 60 and 80 degrees, which we'll be able to control that, and there shouldn't be any excess wind or any of air in that regard. And
are the classrooms set up in that way, or do the students need to manage the environment?
We'll set that up for you.
Okay,
great. Yep.
Anything else?
I believe that is all.
Okay, great.
All
Thanks
right.
for sharing.
Good luck.